Right, welcome to the LLM smorgasbord. Anyone know what a smorgasbord is? A smorgasbord is a large selection of food in Scandinavia, and I was presented this a few times, and we were going through the vast collection of different LLMs are out there. There's over 2 million now, and so there's so many different types, different varieties as we're going to see. It's sort of, I likened it to a smorgasbord. There's various different types of meats and things. So we're going to go through, look at some of these, look at why we use them, why they're going to be important, and how we're using them. I'm going to concentrate predominantly on LLMs that you can run on your laptop, even on your phone. I've got several of them running on the phone. Things you can run on a server, things you can run in AWS. They're all exactly the same, but these are private to you, open source models. One thing's important about LLMs. I mean, why do we need them? It's definitely going to change the world. We know that. I think if I did this a year ago. I think most people accepted it 2 years ago. Everyone would have thought, maybe it's definitely looking quite serious. But I think now we accept LLMs are here to stay. It's perhaps not what's going to take us into AGI, but it's certainly a major step onto the way. What's important to realize about an LLM is it's not just text. When you put text into ChatGPT, you get text out. Most of you now know, sadly not in Europe, or less in Europe, as you get text to image or text to video. These things have sadly been quite blocked in Europe, which is extremely annoying. But you know the case now. You can put images in, you can get them to describe. You can put text in, you can do text to speech, speech to text. What's important though is every time you run through an LLM, there's a latency. There's a few seconds that it takes to go. So if you're going from speech to text, text to text, and then text to speech, you've got 2 seconds, 2 seconds, 2 seconds. You're looking at 6 seconds. So if you want voice to voice, then you're going to have a voice LLM. So this diagram that I was busy just knocking up outside, it's not exclusive, it doesn't have everything in, but it gives you some idea. We've got text to text, as you can see on the right. We've got text to tools, text to code. They are predominantly text models, or they are text models. We've got text to music, text to video, text to image. We've got image to image. So if you've got an image, you can say, edit this image, change this. So it has a bit of text in it as well. So most of the models have some sort of text to provide instructions. We've got text to 3D, we've got image to 3D, text to speech, speech to speech, as I was talking about earlier. These are all the different types of LLM. It is not just text. If we look at the ecosystem in here, the center of the world for LLMs is Hugging Face. It's the GitHub of the world in LLMs. Everything is released here. This is where companies release their models. And there's a surprisingly large amount of information. So when somebody releases a model, they release what's called a model card. And in that model card, for a lot of them, it explains how they trained it, what data they trained it on, how they tested it, how many CPUs they used, how much carbon dioxide was used, etc., etc. You may or may not care about some of these things, but there's a lot of information in there. But most important to the people developing the tools that you will likely use is how the model is constructed. A lot of the models are the same, and therefore they're easy to use straight away, but some of the models use new ideas, and these new ideas are explained in the model card, and then the developers, engineers that supply the tools that you use, such as a llama that we'll get into, need to understand how to unwrap these. I did, literally, this is about 15 minutes old, I did a screenshot from Hugging Face. I can guarantee if anybody goes to huggingface.com, you will find that there are more than 2,141,808, because that was at least 20 minutes ago. And there will be more models already in 20 minutes. That is the top models by latest trending models. And I've added some of these little icons to the side. So the first one is text to speech. That's the one that's trending at the moment. So that will be write something in and the model will speak to you. I don't know this particular one. I can't even read it on my own screen, let alone up there. We've got text-to-text, several text-to-text. Some of these are just text generation. Some of them are conversational things. We've got image-to-text, looking further down. We've got image-to-video, and we've got text-to-image. That's trending. And again, go back in an hour's time. Those will have moved around a little bit. These are the ones that probably got you interested, or certainly got the world interested. The ChatGPT, obviously, the OpenAI, Claudes, Geminis, etc. of the world. We'll be comparing some of these with the open source models, but these are proprietary. If you go into ChatGPT, you're probably not talking to an LLM. You're not talking directly to the LLM. You're talking probably to a switch, which has got some sort of mechanism say, what does the person using this want? How much have they paid? Do they get the primary infrastructure, or do they get the secondary infrastructure? Is the question complex? Do I answer it with this infrastructure, etc.? So you're probably what you're actually going into is a platform rather than just an LLM. This has changed over time. These are often mixtures of expert models. So you're very unlikely going just into an LLM when you go into these. Certainly Perplexity is not a model. It uses its own fine-tuned model, but it's not going directly in. Why do we want open source and why do we want local? There's a whole plethora of different reasons on this. But as I go around our clients, which are predominantly banks and financial services, they want repeatability, they want reliability, they don't want somebody pulling the plug, deciding that something else is going to take priority. They want SLAs. How many of you got SLAs with your models that you know whether they're going to be up and running? How many times have you tried to code something and you've run out of tokens, or the model is not working particularly well? This is very important. Latency. You're not doing an HTTP call, HTTPS call off to a model running somewhere else. Privacy. Many of these models have been absolutely open. The fact, well, open is about the only way they're open. They're open in the fact that everything you give to them, they're keeping. That's it. That's yours. So if you have private conversations, upload a document, it's there. It's staying there. We're in Europe here, and that's going typically to the US, and it's staying there. They'll use it for whatever they want under US law, not under European law. So if you're using private models, what you have stays on your laptop, or stays on your server, or stays in your AWS region that you've got. And cost. If you need a, today, slightly more expensive than usual laptop, but again, a lot of these models run on small phones. I've got most of the small models, they run on a Raspberry Pi. That's 50, 60 euros for a Raspberry Pi. So it doesn't exactly run fast, and so good luck trying to get a good conversation out of it, but you don't need massive hardware. Now, I'd like to talk you through how these models are defined and how you can choose them. When we have a model, it comes out with a name, and it's something B. B means billion. It's the number of parameters that are in the model. Each parameter has a weighting as we go through the model, and that weighting is a floating point number. So as you probably remember, a floating point number has 2 bytes to it. And so if we have a 24B model times 2 bytes, it's 48 gigabytes in size. That is, if you go to the Hugging Face, your 24B model will be 48 gigabytes in size. Fortunately, you don't need to use that 48 gigabyte every time. We have what's called quantization. Bizarrely, you can take this floating point number down and you can compress it down into just 8 bits, 1 byte. Why? Well, it's not really floating point. Well, it is floating point, but it's not using the full range of floating point. These are normally normalized to be between -1 and 1. And so therefore, you can actually quite easily compress this to integers, the number 2, between -1 and 1, range into a byte. And you can even go further than that. You can actually compress it into a Q4. So when you download from something like a Llama or LLM Studio, again, we'll get into these, the default is a Q4. And that's incredible. You imagine going from 16 bits of resolution down to 4 bits of resolution. you don't lose much. What you get is 1/4 of the size, 4 times the speed, and only about 20% of the degradation, 20, 25%, sometimes less, sometimes more, depends on the type of model. That's pretty amazing. It's like a zip, if you like. I like to think of it like this. If you've got a full, as we call it, full fat model, that full fat model is like having a student, a graduate working for you. If you have a Q8, it forgets a few things. So it's like your graduate has just drunk a bottle of wine or a couple of pints of beer, liters if you like. A Q4 is the same as your graduate, maybe with 2 bottles of wine now. They will start to forget things. So when you give them something to do, it will still get done, but there will be little mistakes made. So when you're using a Q4, you will have a few errors. So if you can, use the largest model you can run on your machine. FP16 is the original. So let's assume now that we have a certain amount of size. In this particular one, we've got let's say we've got a 16 gigabytes of RAM that we can use. It must be GPU. No, it's not must, it should be GPU. If you want to run it on the CPU, it's going to run really slowly. So let's say we've got a 16 gigabyte card, and we think, great, let's use the Q4 model at the top. Problem now is you need extra space for the context. The context is the tokens that are inside this. Everything you say, every picture you've got, or everything that you're pushing into the model there is 1 input to a model and 1 output. Not 2, not 3, there's 1 input, 1 output. Everything is tokenized, and it goes into the model as a token. Each token takes up typically an integer or a large integer, and it's quite complex. That is then embedded, and the embedded goes into the attention heads. The problem is that every single token is compared with every other token. So if you imagine a square, your full story or your input goes across here, your input also goes down here, and we now compare every single word or every single token with every single other one. So if you double the context size, you quadruple the amount of memory you need. So I've given you a rough guide at the bottom here. For most models running locally, I would recommend roughly 16K context. That's half a gigabyte. If you just double that, you're immediately into 2 gigabytes. So if we wanted 32K of context with the 15 gigabyte model we had before, it's not going to work in a 16 gigabyte card. You need to bear this in mind. If you're doing coding or something like that, or tool calling, all of that sits and starts using up your context. We can run this in some interesting hardware. I walk around, I didn't bring it today, but it's in my bag in the hotel, a Mac Mini. It's about that big, it's quite light, I think it's less than a kilo, 64 gigabytes of RAM, it runs pretty fast, and it is absolutely superb for working on. Laptops like this one run up to 100 gigabytes in size. Not the cheapest, sadly, but they are still better than many of the NVIDIA cards out there. So if you want to get some hardware, there is plenty out there, and I'd really highly recommend the Mac Minis for literally, I think it's 600 euros. You can get a reasonably powerful machine that will run quite a lot. But again, a lot of this stuff you can run on a Raspberry Pi. Now I'm going to show you some code. Now, this is a Java conference, so that is Python. Why is it in Python? Well, actually, it fits on the screen. It's one of I started like Rod, started using Python with AI a couple of 2-3 years ago, and it was more of the language. I'm now getting back into my more native Java in this. It fits on the screen. The bottom half is the test questions I'm going to ask. What I'm going to demonstrate here, I'm not going to run it, but what I'll demonstrate in this is just how fast these run. The top is the timing. It's using a Lambda, and it's in Python. I did actually vibe code this into Java using Java 25, which I'm finding pretty cool. This is most of it. The bit's missing, which is yet another page, because there's 2 pages on there, sadly, is the lack of native support for JSON in Java. Yes, I know I can bring in libraries, but then you need the Maven, the POM, and all the other bits and pieces. So this is one of the reasons why it's just easy to put it up in Python, but it runs equally well in Java. All you're doing is making an HTTP call. I'm going through a list of questions, and I'm asking the model that is sitting running on my machine, what is the answer to? And I'm telling it with the system prompt to reply very simply, don't give me any explanations. These are the answers that come back. What I want to point out here is this is running on a local machine. I am asking it simple questions. Now, you're not getting an LLM, I hope, as a source of knowledge. Because if you think the entire source of Wikipedia can fit in 4 gigabytes, think again. I walk around with it, sadly, the full entirety of Wikipedia, 110 gigabytes on my phone, and it's on my laptop, of all the photos, just because I like data. But you should be getting an LLM for the process, the thought process, the reasoning. Yes, it needs some general knowledge, it needs some common sense, but you're looking for a student. This student could have come out of a university. It's equivalent. I'm just giving an equivalent. You're looking for a student that's come out of a university in Indonesia. Why on earth should they have any general knowledge? Obviously, I would imagine of Holland, but of other places in Europe. Does it really need to know the population of Antwerp? So don't expect these models to come back with that sort of information. Anyway, the point here is, if you look at these, we're getting answers back in 150 milliseconds, 119 milliseconds, 215 milliseconds. Those of you may have noticed, if you're a little bit observant, the further across the screen it is, i.e. depending on the number of tokens that come back, the longer it takes. And that's because each token takes a certain amount of time to compute as it comes back. So if you're looking for one-word answers, the shorter it is, the quicker it runs. The importance of this is, if you're tool calling and that answer coming back is, call this tool with these parameters, call this tool with these parameters, you're getting that tool call in 200 milliseconds. And if you're sitting in an agentic flow, as we do, this is really fast, really, really fast. So different types of models. Let's just go through a few of these. We have instruction-coded models. These are what you will typically be using. They follow instructions. It's all very well having a chat with a model to say, I've got a headache, what should I do? And it'll sit and chat with you. It doesn't really matter what it outputs in the mode that it outputs with the personality that it comes out. But if you want a tool call, you need it to put the brackets in the right place. You need it to put the parameter in the right place with the comma after the parameters. That is instruction calling. If you want to grade something to say whether it's positive, negative, or neutral, you want it to actually use the right words, not say positive with a capital P, or say this was positive. You just want positive. That's an instruction following model. So you need to look for instruction following models if you're working in this sort of environment. If you just want to chat, then you don't really care quite that much. The next thing is chain of thought. This has become pretty much the norm. A year ago, it wasn't. With chain of thought, what is happening is you're giving it some instructions to do, and the first thing the model is trained to do is to break your instructions into smaller parts. Now, one of the tests I do with the models in my test suites that I go through is to say, get the temperature in Madrid, I think it's actually Paris, get the temperature in Paris in degrees C, convert it to Fahrenheit, and then convert that to Roman numerals. Okay, so it's got 3 function calls. The first function call is to find the weather. I don't actually call the weather because that takes time. There's no need to. I just need to make sure that it's actually calling the function. It always returns whatever it is, 36. 36 turns out to be 100 in Fahrenheit, again, second call. And then the third one is taking 100 and creating me C. And so all I do is test C on the output. But what the model is doing is breaking down. First, I need to call this tool. Then I need to call this tool. Then I need to call this tool. It can't call the Roman numerals before it's got the temperature. So this is starting to get into a sort of an agentic flow. And this is where the models, with part of the reasoning now, with the chain of thought, is starting to move into this process. So you want a model that manages chain of thought. Reasoning is the next step. And this first came out about a year ago with a model. It wasn't Qwen who invented it, but it first came out as a model that you could use from a model called QWQ from Qwen. And this was quite fun. When it first came out, I literally sat there for days just like when some of these image models came out a few years ago. You could put stuff in, and you could sit and watch the reasoning. Now, underneath this, I just asked it, what's the best cocktail, short cocktail using gin? And the bit on the right, which you obviously can't read, is part of the output, and it's reasoning with itself. When I say reasoning, I use the word lightly. It's been trained to have self-doubt, to list out the information. And again, to explain how the model works, you need context, which includes not just your input, but your output. And this is why if you've got a reasoning model, you need 16K or 32K, because all of that text on the right-hand side goes back into the model. And this is sitting in a circle, basically. So as it's generating tokens, those tokens go back into the model, and it generates the next token. This is why reasoning works, because it's generating more information, feeding that information back into the model, and it's using the information that it's created to list down to create the next tokens. So if you've got a reasoning model, particularly a reasoning model with tool calling, you're going to need a lot of context, because this pops out, and you're going to need a fast model. This is why these small models that spit out on a laptop 150, 200 tokens a second, which is pretty fast. You'll see this come out faster than you can read it, blip, 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 line by line, very, very quickly. But that's effectively what it's doing. Now, this model got it completely wrong. Because the best cocktail is a Negroni, and so this model was rejected from the testing framework. Just joking. It got a pretty good answer. It wasn't too bad. But these are fun things that you can try. But how do you test that? Well, you can get another model to actually say, did it include the following? And so you basically just using models. Now remember this as well. Models are trained on human text. They are extremely good. They spend their entire training time reading. They are extremely good at reading. They are not very good at writing. We use them as generative AI. It's one of the things they don't do quite so well is generate. They're actually good at reading. So if you get your model to write something, you can use another model to read it and say, judge your own text, judge your own output. In fact, it doesn't know it. It's its own text, because each model has no memory. So you can feed itself back into itself and say, judge this, is it good? Is the output good? And they will be orders of magnitude better at reading than they will be at writing. So chain of thought and reasoning are now in models, and Qwen again was one of the first that came out with this. They started with QWQ, and then earlier this year, at about March or April, they came out with a model. There are a number that have done it now. Mistral's done it. OpenAI released a model called GPT OSS, which is also reasoning. And they allowed you to switch the reasoning on and off. And some of them didn't. And so you have a reasoning model, and it's actually quite annoying. If you want a quick answer, it goes off and reasons, and you've got to limit the reasoning, and that's very hard to do. It's hard for the model to know when it's finished. And so it slows things down. So then they put a switch in it to say reason or not reason. But that impacts the quality of the model, because you have to train it to have the switch off, and you have to train it to have the switch on. And so now, and we're literally talking just the last few months, they're starting to release models which are called thinking models and instruct models. So if you want a quick answer, go for an instruct model. If you want a better answer, go for a thinking model. It is exactly the same as if I ask you a question and I say you have 1 second to answer. Your brain uses a different part of the cells to come back with a quick answer, the fight or flight type response. If you've got time to reason about it, you can think, oh, if I did this, maybe that, it might affect this, and then my wife will do this. And you've got all these different things. That's the reasoning that's going through. Let's touch briefly on RAG. This isn't an LLM, but RAG is one of the very first things 2 or 3 years ago when we started to get into the sort of going around to companies saying we can do some really cool stuff with AI. And of course, they want everything private. And of course, this was why we started working in private models. So RAG actually doesn't need that much power. What you're doing with RAG is that you're splitting the documents into small parts. You're embedding it. So you're actually using the first part of the LLM. And an LLM is basically a tokenizer, embedding, and then the attention heads, which compare all the embeddings. And the model companies just I would say, cell. They produce just the first part that basically does the tokenizing and the embedding. And it's exactly the same as the full model. You can actually use a full model to do the same embedding. It's exactly the same functionality, but you have extra memory that you don't need. So you embed it. The embedding is increasing incredibly. The embedding models we used to use were limited to just 500 tokens or even just 700 tokens. So you had to have really small chunks. And it got rather hard. Today's models will work with contexts of 2,000, 3,000. So you can put entire pages into the context, and they're incredibly good. You take the documents that the embedding has found, similarity search, semantic similarity search, and again, they work across multiple languages, which is, again, new this in the last year or so. And you send those to the LLM saying, here's the user's question, using the context provided and only the context provided and not your general knowledge, please answer the question. And most models, even really small ones, are good at that, and you can get really, really quick, fast answers out of this. Tool calling at MCP. As we've got better and better models, and the models are better and better at following instructions to follow them precisely, this has only really happened in the small models in the last year or so. We had to have really big 70B or larger models to actually do tool calling. And it was quite annoying because they function slowly. 70B parameters, you've got a lot of memory, they function slowly. To do tool calling was a slow process. Today, it's de facto. And so the models we get out of even a 1.7B model or a 4B model do tool calling. And it now means that we can, the tool calling syntax is almost identical to MCP, the Model Context Protocol. So these work extremely well. Again, the smaller the model, the less tools you can put into it because it's got to remember them, and it's also got to distinguish them. If you gave it two weather functions, one takes a city and the other one takes longitude and latitude, the model's going to get confused. So you need to limit your models, limit your MCPs or tools that you put in there, and you've got to describe them well. But again, they're all using context. So bear that in mind. You need if you've got a lot of tools, you need a slightly better model. But this is interesting. This is just a graph. Now remember, every single test or comparison that you see is one of about 50 different ways of comparing a model. So do bear that in mind. There are so many different ways of comparing models. Take it all with an awful lot of salt. Along the bottom, we've got the release date. Ignore that. It doesn't mean that they started recently. All the old ones were just taken off the graph. So these are just models which are up to date, the most up-to-date models. It's less relevant. What's important is the quality out of this. I wish I had a laser. I don't have a laser. Anyway, you can see the sort of black dot right in the middle, and I've just limited this to small models. These are really small models, 20B. The one in the middle is the GPT OSS 20B. They made a 20B and a 120B. It's pretty good, but this one in the top right is incredible. It was released last week. It doesn't even work on a Llama yet. I've got it running on my machine under a thing called MLX, which runs, I can test it, run it. I have run it a bit. I haven't tested it with my tool calling models, but it's way up there. It's only a 15B model, and it's up there with the latest open source, the latest models, proprietary models like ChatGPT 5, Sonnet 4.5, etc. It is absolutely incredible. So this is the way things are going. This happens every week, as you'll see from some of the graphs. I want to touch briefly on the visual models. Visual models are more surprisingly useful than you might think. I don't know if anyone's anyone here ever tried to copy something from a PDF. Yeah, you know what happens. You do the select, and it selects bits from all the different paragraphs, and it selects a bit of the graph and all sorts of stuff. PDFs were designed to be visually to be printed. They are not good input. What you can do now is you can do a screenshot of the PDF. You render it as a screenshot, and you can now use an LLM to go through this. Now, this isn't a PDF, but it's to give you an idea. These are, I'm into astronomy. This is a graph off a website, and I built a little app. Actually coded it. This was before vibe coding stuff. That's probably my last code I wrote. and I had to get the information from the graph on the bottom for a particular gain as in sort of how much you turn the camera up for sensitivity, to work out the read noise in electron volts, and I'd have to read each of those. With the LLM now, with this simple prompt, I can say, using a graph, what is the read noise at 50, gain equals 50, and it identifies the right graph, reads the information off, gives me the answer. That's pretty cool. And you can do that on a 7B model running on your laptop. Other things you can do out of this, we can say, find me all the pictures of beer in this image. Return, and we're now starting to give it some instructive output. Give me the output in JSON and basically label it. Write a tiny bit of code to put the labels around it, and we can start to identify things. But we can identify some pretty, beer isn't that weird, but we can identify everyone who's not wearing a helmet, everyone who's wearing a blue shirt, and the models will start to identify these things. Okay, not the most useful thing, identifying beer. This is a use case which we partly funded and is in production. It's basically for taking diagrams that people draw for drafting when they're creating if you were creating this podium here. It's got wood on the side, it's got metal. How much metal do you need? What's the length of the metal? How much wood do you need? How much paint do you need to paint the wood, etc. This is one of like 8 diagrams that come, and just, you can't see it obviously, but the next slide will just be zooming in. On the right hand side, it will lay out the wood as to how much can we get cut out, and it does this. This takes people like 2 to 3 days to do, and it's giving you a bill of order on the right, on the bottom right. We just scale that up just so you can see the visual LLM is reading all of these numbers and it is formulating a picture. We can then use a 3D model and actually present that using Blender to make sure that the podium that we had on paper in 3 different orientations from the top, the side and the front is actually the podium that we thought we did. And we've now got a 3D version of that. We can say, yep, that represents it. And it now tells us how much wood, metal and glue that we need. That's one use. Rod's sitting in the front. We're using Embabel. This is an agentic framework, and we are using it 100% locally because we're working with banks. And we're able to use local models, not obviously on the laptop, but the bank is hosting, and this is doing ID processing. So it is checked that the passport has the appropriate validity date, that the name on the passport is the same as the name on the documents, etc. This again is another real use case where we are actually, and this is the putting people out of work stuff. AI is putting people using AI, or putting people who don't use AI out of work. So this is part of the process. We're using a lot of cryptography. We're using a lot of signing in this process. It's not quite AI on its own. Text to speech, speech to text. I think you've all got used to this. And one of the ways of understanding that something has been adopted is the fact that you pretty much forget about it. Ethernet, for example. You walk into somewhere and say, Alexa, do this. And I'm not going to say the other word because my devices will start waking up. But the SIRI one are the same. We've been doing this for 10 plus years. That is speech to text or speech recognition. It's not using an LLM to do it in this particular case, but these are really cool now. They will, as you can see my text on the bottom as I'm speaking, that is using speech to text. Je ne sais pas si ça marche en français, mais on verra. Ah bon? No, see, it's got it wrong. So there's a bug. We'll feed that one back. That is text to speech. You can then do the speech to text. You will notice that when you do text to speech, you will go, oh, that sounds like a computer. That is getting better. But the same is true if you ask a human to speak. They might be foreign. They can understand everything you're saying. But as soon as they open their mouths, you go, oh, that's a foreigner. That's a French person trying to speak, or that's a German. And so you'll get the same. So these things will get better and better as we go through. And it's improving at incredible speed. You saw that the board that I put up earlier from Hugging Face, those trending models, these are just coming out on a literally a sort of every few days. We get better and better and better models. There are now speech models. If you have time, go to a website called Sesame, SESAME, and on there you'll find a demo from Maya, and it's one of the few things that works in Europe, and you can go on that and have a chat with it. I can guarantee you, if you're in a quiet, don't do it in a noisy room because it picks up everything. Do it in a quiet, shut yourself in the toilets, and start speaking to your phone, and it's uncanny. You'll be speaking to it for ages. This is how quick it updates. These are again, using yet another rating, take it all with a pinch of salt, but it's representative. All the black models here are the latest state-of-the-art models. The one 4in is Sonnet 4.5 that came out last week. The blue one on the right of the group of 4 is the new one, the GLM model from Z.ai that came out this week. That's 4.6, it was 4.5 before. And this April 1.5 15B is entirely new. I wouldn't say it came out of nowhere. The company's been around for some time, but I think the previous model was a 1.0, 1.2, something like that. But this is just leapfrogged up into the league table. So this is how quick it changes. I have to update the slide literally every day. Here's another one, and this is important. What I want to show you here, I've labeled a couple on there. The models that you have today that you can run on your laptop or on a reasonable server are as powerful, if not more powerful, than the best model you could find, absolute best model you could find a year ago. They are as powerful as any model you could find 6 months ago. So if you follow this, the 4. So where you see the April 1.5, just above that is the GLM 4.6. If you follow that across, just 6 months ago, the only thing that was close was the new Grok model, which had just come out. Anybody here use Grok? There's Grok with a K. It is a brilliant model. I mean, I'm not a huge fan of Mr. Musk, but if you've got it on the phone, it's crazy. It's crazy good. So that's the one in the purple. You see the little sort of highest one, and 6 months ago. It's a crazy good model, but most of us don't use it as an API. So the models today are better, excluding Grok, are better than what we had 6 months ago. Anything, better than anything we had. And they run on your laptop. Go back 1 year ago, and OpenAI had just come out with 04. So that's where we are. Anyway, last couple of slides. Where are we going with this? I think that LLMs are bifurcating. I think we're getting two versions here. We're getting the craziness of the hundreds of billions being plowed into these models, predominantly in the United States. This came out, I think it was last night. I screenshotted it last night because, you know, these social media things, you find something, you think, oh, that's really good, and you go off to do a little bit of research, you come back and it's gone, and you can never find it again. So I literally screenshotted it. It's the bubble, the sort of NVIDIA, Oracle, Microsoft, OpenAI, AMD model of all the money and chips going left, right, and center. This is going to burst. It will burst at some point. We had a little a glitch in January, but it's going to go. And those are the big models. But when they go, for anyone using the small models, it's not going to have any effect whatsoever. So we'll just sort of leave them to it. It's sort of quite nice to watch. The other side is the LLMs, the small LLMs. So the road ahead from these, there was a paper that was published recently by NVIDIA on the 15th of September, that small models are basically the future of agentic flows in this. You don't need these large models. We build stuff just as we write software. We build it into smaller and smaller and smaller modules. We don't write everything in one great big public static void main. It's into little functions. We're in Europe. I am actually European, not just a British, but I actually have a European passport. So I strongly support Europe in this. This is definitely not the end of the race. If the bubble bursts, it'll just be starting a new race. So if you can support Mistral, it is a damn good model. It is also open source as well as proprietary. So I'm going to be a big supporter of that. If you want to know which models to use, you have to test. Use them for your case. So last slide on these, some tools. It's worth taking a photo of this, just stuff to get you started as you go up. Llama.cpp is the base of everything as it comes off Hugging Face, so nothing gets out until it's been through Llama.cpp. in C++. It's on GitHub. You can download it, run it. It's very simple to use. Ollama is probably the easiest to use. LM Studio, got a slightly better UI, a little bit more flexible. MLX runs just on the Macs. VLM doesn't run on the Mac. And then there are some models here which you can give a go. They're all sort of fairly small. And with 15 seconds, 10 seconds, 9 seconds, sorry, to spare, thank you very much. Have 3 seconds to ask any questions. No, sorry, gone, time up. Please don't forget to vote. If you've got extra voting tickets, because it's the end of the second day, you might as well just throw them out. Thank you.